Great.
All right.
So that was a productive lunch.
I didn't take a break, and I just kept programming, and now the tests pass.
Okay.
But there's still work to do to add asserts and make sure we test all the cases properly. And I need to show you about the fun new edge case I found.
Oh, awesome.
Let's do that first. You're gonna love this one. Um,
Okay, cool. I'm getting a
so,
tiny bit of feedback.
all right, let me adjust things a bit.
Okay.
All right. So this case is, well, let me copy these things so I've got something to work with. Yeah, so we allow removing up to a whole node of capacity, right?
Yeah.
And so what you can actually have is something like this. Whoops. If you just totally forgot, is it possible?
Oh, wow.
And so I fixed
Oh
this by
man.
just
Yeah.
restricting our batch size to half node capacity instead of full node capacity, which
Okay.
eliminates this problem. Otherwise, it
Okay.
gets a lot more complex.
Yeah.
That's like just like a whole nother dimension of things we would have to handle.
Cool. Good call on that. Yeah.
Or actually, maybe it wouldn't be. Because you see, then we always have a full node we just delete, and then we kind of do the same thing.
Yeah.
But maybe it's fine like it is now. We can think about that as we go through the code. So that was just my knee-jerk reaction to this, was to just kind of cut the batch size to half node capacity, so you don't have to handle this case, which is probably fine for our use case.
Yeah.
I think we should probably just stick with that, to be honest, because we won't really be doing batch inserts or removes of near node capacity in our actual use case.
Yeah. Yeah. Yeah, that's fine.
Cool. And yeah, that's the new fun edge case, but we don't have to deal with it though, because we can just make the batch size smaller.
Cool.
And so I've just here, I can probably get rid of some of these debug prints now. So I've just added this half variable here,
Awesome.
and then we go use half here instead of node capacity. Yeah. So
Can that
let's
happen?
go through this code.
Can that edge case, how does that work with the very last node, which we allow to be empty?
This edge case, or which one are you talking about?
That's we can't possibly have it. Yeah, I'm wondering if this kind of edge case, if we can get an example where it interacts with the last node in an interesting way.
Okay, yeah, that's an interesting question. And so it would be something like this. Well, no, it won't. I don't think we can actually have it change things there, because the second to last node still has to be at least half full. And so in the worst case, you're removing a little bit from the last node. The last node's special because it can be less than half full. So that's the special case we need to examine. Or we can just like delete these nodes here. These ones are gone. This is the last node. It's special case, so it can be like not totally full. This one still has to be at least half full. And so you'll have a partially full node here. You can have, at least has to be at least half full.
Yeah.
And so you can end up with this then being the last node, but my code seems to handle that correctly currently. So
yeah, and because we limit it to half a node capacity, there's no way that it can span from the last node to the third last node.
Yeah. So because limiting it to half node capacity, and we know that nodes have to be at least half full, then the last node, there can't be a node after this one where it could span to. Because if there was, then yeah, it could span because this is less than half full, but there can't be any node after the last node.
Nice.
So,
awesome, Isaac. And good call on simplifying it just then cut the capacity in half.
Because we have this loop. I mean, it just like amortizes over a slightly smaller thing. And so in practice for our use case, it won't matter at all, I don't think, that we have a smaller batch size for this part.
No. And that's still better than restricting the remove to only happen in a single node. This is now still much better, because if if a delete spans the edge of a node, then it's going to
Yeah. So let's see. I'm trying to think about the best way to walk you through this new code. I think we should start with this merge node with next function, which needs to be renamed because it doesn't really do that anymore. But let's go through this dot comment. And so we allow node to be empty, which kind of takes out a bunch of special case code from that stuff up above. We allow counts and indexes in the next node to be invalid. We say the pointer must be valid. We say that the next node length, this is actually not true. This is not required. Never mind. Because we allow it to be the last node. We handle that especially here. If the node is already at least half full, it will not do a merge, but will still move elements next node to the start of the next node and fix up the metadata. And so we can pass in node doesn't really have any requirements on it. It needs to have proper metadata, but it can be empty completely. It can be over half full, and this function will do the right thing. And then elements next node also doesn't have very many requirements. It just needs to be, it can only be less than half full if it's the last node. That's the only like tricky thing. So it needs to be a valid node.
Okay, and that elements next node can be empty as well. It can be an empty slice.
It can't be empty.
Okay.
Actually, so I think we should assert. Actually, we do assert that it's greater than or equal to half, or it's the last node. Yeah. And even if it's the last node, I think we should assert that's greater than or equal to 0.
Okay.
Let's try that. I'm pretty sure we require that. Elements. Okay, so I want to bring that back to that comment I had here. Must be greater than or equal to node capacity over 2, unless it is the last node. Kind of like it must always be greater than 0. I think that is okay. I think an okay thing to assert. And we can add that back here. And see if the tests still pass.
Nice.
Yep. That's a good thing. Nice. Yeah, so that's kind of what this function does. It just handles all those cases properly. And if this is like what we had before, these two cases, and I've added 2 more. This one's just an optimization. We don't need this one, but it prevents a copy in some cases if A count is 0 and the B elements don't need to be moved. And so it's just, instead of doing this copy, it could be, it does the exact same thing as this case, but instead of deleting node B and moving all the elements from B to node A, it deletes node A instead and just doesn't leave the elements in B in place.
Okay, cool. Nice.
But it avoids this copy in that case.
So it just,
this is exactly what we had before in our old thing.
Okay, that's if B doesn't need to be shifted.
Exactly, yeah. That's if we compare B elements.pointer with B pointer. I've probably need to work on these variable names too. I wrote this pretty quickly.
Cool. No problem. I was just wondering, is there a case where B elements pointer equals B pointer?
Yes, there is. That would be something like I guess this node, this one. Then this would be B or elements next node is that we pass in as this whole slice.
Okay.
Even though this is a valid node, we just ignore the metadata, and we just to avoid special casing in our code, we just pass in this whole slice and then this.
Okay.
And this could, however, be empty because there could be nothing in this node. This could be like that, in which case we actually don't want to do this copy. We instead want to just delete this node. But if there's just a tiny bit of elements here, if there's just a tiny bit here, then we actually do want to do the copy, or it doesn't matter because we have to do the copy either. We have to either like copy it like that and then copy this stuff here, or do the cheaper option and just copy all of this to here.
Okay.
Cool. Yeah, that's what that case is.
Okay.
Fix up this diagram. Okay. And then the next case is if total is less than node capacity. If the A and B counts here fit inside one node, in which case we just put them in the same node. We copy from B to A, fix up the metadata, and then remove B.
Okay. Cool.
This function also assumes that indexes of following nodes after B must already be valid. Well, this function doesn't rely on that, but it doesn't do anything to fix up indexes of the following nodes.
Yeah.
It just assumes those are already correct.
Okay.
And we should document that too.
Okay.
And the next case is if A is less than half, but that B and A don't fit in the same nodes. This is where we need to then divide the total amount of elements between both nodes and then kind of redistribute the data. And so here we've got to do 2 copies. One from the first chunk of B elements into A node to make it to fill it up to A half, which I've used as total over 2, and then B half is what we leave in the B node, which we then need to copy to the start of the B node.
Okay.
You want to see that visually?
Yep.
So that would be like a 3-step here. Here it is, I think. Yeah. So there's this case where we have this is like A elements here, and then B elements are these 2 things, and then we copy. Whoops. So this is like our inputs. This is the A elements. And these are the B elements here. And we copied this part here. That's the first copy in that code, and then this one to here. That's the second copy there. That's this case.
Yeah.
And we just split the data evenly between the 2 nodes, because I think that's going to give us the best characteristics. That's the simplest thing to do. That keeps both nodes evenly full. Then we set the metadata.
How does it work with, do we want to make A half slightly smaller than B half?
It doesn't matter here as far as I can tell. I think I just kind of picked one. I guess I picked the one that that use a simple division operator instead of a function.
Yeah.
So I think it really doesn't matter here.
Doesn't mean that A might be less than half sometimes.
Yeah, A will be slightly less than half sometimes. You're right, because the total could be an odd number. That's totally possible, but it will still be at least half full. We do have asserts here that A and B are greater than or equal to half full at the end.
Yeah.
Yeah, and then all we need to do is fix up the metadata for B. Counts and indexes are the only things that are invalid for B when we enter this function. And the place of the elements inside the node. And we've just fixed the place of the elements inside the node here, and we fix the counts and indexes here, and then we're done.
Okay.
Then we're fine.
And then A is already half full.
This last case. Sorry?
Yeah, the last one is where A is fine, and we just need to shift B's elements. Okay.
Exactly. And we do the same optimization where we check if we actually need to shift anything or not first to avoid. That would be then this case. Well, I don't know. Does it actually happen anywhere? Where A is over half full?
Yeah.
But then, I guess, it's this case,
isn't it? Yeah. Yeah.
It's this right here where we do the merge on these 2 things, and then we just want to do this shift. But it could actually be the case that we had something like this. Maybe, I don't know. Maybe it is actually, it would be the case where we're only removing stuff from one node, and we don't remove enough to bring this node below half full. So we just remove a tiny little sliver from the node, and we don't actually have to do any shifting. We just delete that bit, and then it's fine.
Okay. Nice work, Isaac.
Thank you.
Yeah. How does it look at the call site before we get into this?
So, I just wanted to explain this function first, otherwise the call site won't make as much sense.
Yeah.
And so We still have roughly the same control flow. So this is the case where there's only one node removed, and that hasn't changed at all, I don't think, from what we did yesterday.
Yeah.
Except I think I might have fixed like one slight bug or something, but we just call this, do we need this case still? Yes, we do, because we can't do a merge on the next node if there is no next node. Yeah. So this one we don't think we need anymore though. Oh, we do know we need this if the last node. We only need this if it's the last node. So we can actually put this inside the cursor inside this branch. We don't need it in the other case. And that actually makes this code a bit simpler then.
We do need it. It could be that we've deleted everything from a middle node.
Right, so, but merge next node with next handles that.
Yeah. I think it's better not to rather have it explicit here.
I just want my goal of this was kind of to reduce the number of return statements. I think I've almost gotten rid of all of the early returns here. That was just messing with our control flow before. There's like one more here, but we could also just make this one an if statement too, and just like let everything go through to the end.
Yeah.
Because the early returns were kind of messing with us before, especially with this kind of thing. And so my inclination was to do this and just not have the return at all.
Yeah, I don't mind the early return here wasn't a problem. It was more in the next branch where it got tricky.
Yeah, where we had multiple of them, but
Yeah.
I feel like, so what I've done here, I think, is I check if the node is not the last node, then do the merge. Otherwise, I check if it's empty, then remove it. So if it's the last node, we have a special case to check if it's empty and remove it here too. So I wanted to mirror that control flow here. Then I come back to that since I made that change.
Yeah, it's nice. I like to rather see everything that if it just affects a single node, then just to see it all without having to go further.
Node count. So if cursor.node is not the last node, then we would do that. Otherwise, we would say else if this is what the alternative looks like.
Yeah.
And then whoops, that was the wrong copy thing. And then we delete both these early returns. And what have I messed up here? Yeah, there we go. Which is more concise, I think, and also has simpler control flow because there's no returns. There's just one or two branches.
Yeah, there's a bug there though, because if we are on the last node, or I don't know, maybe I'm wrong. Should we just run the test?
I'm pretty sure it'll still pass, yeah. Yep.
Okay. I actually prefer the other way we had it. I find it simpler. I find this is more like a compound. In VSR we do it where we've got lots of if statements without else branches, and it's an if and then return. And what we want to do is you start off with a lot of complexity, then we shift complexity out the way, shift complexity out the way. Here,
yeah. I was doing that before, but then it got really just too much to manage because there was too many separate control flow paths. And how I kind of made this code possible was just kind of trying to unify as many paths as possible into this one function, and just eliminating all the early returns. So I've kind of been tending towards handling all the cases the same, kind of like we do in this function where we handle literally every case the same. Here, I've been trying to reproduce that kind of control flow here.
Yeah. Yeah. No, I mean it's good to try that. But I find this doesn't read as easily to me. It's much harder to see how are we going to hit that else branch. Oh, okay, it depends on that. And whereas I think here a better style is if we deal with the tricky cases, get them out of the way. If we know
Yeah,
we're
but
just
then
gonna, if we, and it also makes sense if we know we're just going to remove the node, we can do that as soon as possible and break out. Uh, uh, Before we even get to deciding whether to merge. We've got here it puts the flow kind of the other way around. Uh,
well, I don't know. Yeah, I guess I don't care all that much. I think this
yeah,
is just more concise, cleaner code because it uses the same function you use for everything else. There's less
yeah.
like special cases here and less early returns. Control flow is simpler, but this is the alternative, I guess.
It makes it stand out more if we have it like if it's now empty, just remove it. Okay, now we're done. Are we on the last node? Okay, we're done. Okay, now we're not. Now we know. Okay, let's merge with the next. Uh,
Yeah, but this handles this case if you're not in the last
I
node.
I know, but
Um,
it makes that function too powerful. What I would prefer, I still think with merge node with next it works now, but the code will be much simpler if we break it up into two things, merging A and B, and then merging the result of that with C. Because merge node with next does too
I
much.
disagree.
It's fine. We can agree to disagree, but it will definitely make it a lot simpler, the code. Uh,
I don't think you can make it simpler than what it is right now, but I'd
yeah.
be happy to be shown differently.
It would be nice to try it,
I mean,
just to try it out. I'm pretty sure it's going to be a lot simpler to have it in two phases rather than try to do both in one. The other reason is it's kind of coming
I
back to that
don't know what two
principle
phases
of
you're talking about really,
okay,
because
okay,
this code works. I mean,
yeah. So I can show you what I'm thinking if you're happy to try it out. Uh, the principle that I would like us to do here is that we don't make merge node with next so powerful. It should have less stuff to think about. And where we merge with a node that is valid, that should also be simpler. What bugs me at the
why
moment is
not
that
just have it
we,
follow the same path though? Like this is just less code. Um,
so
there's
let me
one less special
explain.
case to handle, and so I think
Yeah.
that's simpler.
It, okay. You see, we have to try it. If we don't try it, we're not going to know. We have to see how it looks. So we've seen this version, which is great. I mean, it's great that it's working, but I do think we can get a lot cleaner still, a lot simpler. And you see, the principle that we don't have here is we don't have the single purpose principle. So we don't have like that cryptographic idea where you want one thing to do one thing. We're now using merge node with next for two different kinds of merges. So it makes it more tricky than it needs to be. Uh,
Yeah,
so
but we do the same thing here. We use the same code for all different kinds of
yeah.
inserts.
So Isaac, I'm
And
just
this,
proposing we just try out this other version as well. Let's write it out and then we compare. We can actually just look instead of, you know, debating
all right.
whether it will be clean or not. I'm pretty sure we're going to get to, who knows, maybe it's not, but let's give it a shot and see how it looks.
Okay. So I'm just gonna leave this version as is. I'll get rid of the
Yeah,
debug prints, I guess.
yeah,
And then we can like do a separate version and compare simplicity and lines of code and whatnot. Do you want to like see the rest of this code to have like
yeah,
a
yeah,
good
yeah,
understanding of the problem before we do that?
yeah. Cool.
I can also get rid of some of these useless comments.
Yeah,
Um, yeah, remove from only one node. That's fine, I guess. Okay, so here we handle the case where A is greater than half. Um, and first thing we do is just shift the remaining elements in B to the start of the B node. Um, this is where A is greater than half, and so now what we're gonna do is we're just gonna try and merge B with the next thing. Maybe B is already greater than half. If that's the case, it's fine. Maybe B is the last node. In that case, we just hit this branch.
Yeah.
Maybe the node after B is the last node. That's also fine. But we just, if A is greater than half, we just try and merge B. Maybe we do nothing in that merge because B is already greater than half and everything is fine.
Yeah. Just so
That's
I
how that
can,
branch works
so
pretty
I
much.
c- just so I can understand, just to like load it up into my head, can we just scroll up a little bit before the, okay, so we above the very first branch, that's where we handle single
Yes.
node
So
only.
this is the single node branch.
Yeah.
And now we're inside. Now we know that we have two nodes. And now if we've calculated remaining A and remaining B. I fixed this calculation, by the way, too. This was wrong before. I think it's also
Cool.
too long now.
What
Yeah.
did we have before there?
Um, we had just the subtraction backwards, I think is what it was. Um,
Okay.
I'm not sure how we managed that, but we just kind of flipped something around. Um,
Okay.
this is now count the total number of things being removed minus the amount of things being removed from the A node, which will give
Yeah.
you the amount of things being removed from the B node. And that's where we want to start our remaining B slice.
Yeah.
Um, yeah, I can just wrap this, I guess.
Cool. So this one is nice because A is all good.
So A is all good, and then now we just fix the metadata for A and B, and then we try and merge B
Yeah.
with the next node. If that's fine, then we're done. If B is the last node, then we do the same thing. It's the same control flow as here.
Okay.
We just check if B is the last node, then we check if B is empty. If it is, we remove it.
Okay.
Otherwise, there's nothing to do because the last node is allowed to be less than half full.
Okay.
Um,
Can we just scroll up a little bit? I just want to just step it through. So because we know that we've got two nodes at play, we know that remaining A has to be it's got to be at the beginning of A. It can't be that
right,
remaining A is needs to be shifted. So we could
right.
assert something like that, um, but it's
I mean,
fine.
yeah. I think this is just how the code, how remaining A works.
You can see
You're
it
starting.
right
This is a
right
hard
above
coded
that.
zero here.
Yeah, yeah. Okay, no, I'm just coming at this just fresh. So that's perfect like that.
Oh, good.
Okay.
Yeah.
So then we're going to shift B internally within B. We're going to update A's count to be what's left in A. We're going to update B's count to be what's left in B. We've got a nice index update for B based on A. Can't go wrong. Check B is less than node count. Uh, okay, why do we do that assert there? Should we hoist that up a bit?
Um, I don't remember why I do this here. I think it was kind of paired with this if statement. That just asserting B
Of
is
course.
a
Okay.
valid node.
Okay.
You can stick it there if you like.
Okay. Cool. That's it. We kind of assert that when we take the pointer up above, outside.
We do actually, yes. It's kind of redundant, I agree.
But locally, it makes sense if it's right next to that. Uh,
Yeah. And then we update all the indexes after B.
okay.
It's saying if B is not the last node, then update all the indexes after B, subtract
Okay.
and count. And then we
Yeah.
grab the elements of the node after B. We just use B plus 1 and grab all the elements of that node. This is like usually in our diagrams, there's this whole node. It's just this slice. And then we use the
Yeah.
same code path, passing that to merge.
Okay.
Um,
Okay.
and so then if B is over half full, this won't do anything. Yeah.
Cool.
If B is less than half full, it'll distribute the elements as needed.
Okay. At this point, so here we've already fixed up B. So the only reason we want to call merge is just in case B is less than half. Then we want to
Yep.
merge it with C. So this is the very easy merge where this merge function for this case can actually be much more restricted internally. It doesn't have to do too much.
It could be, yes.
And we're also going to only exercise a few branches in it.
Yeah.
Yeah.
Or you can use the same function for everything else as well this way.
No, I know, I know.
Um,
I'm not. I agree with you. I totally agree. We can use it for everything. Uh, okay,
yeah,
so
this is the case that's more interesting for this merge function. The next
exactly.
one,
Yeah,
remaining
exactly.
b is greater than half, but remaining a is less than half. So this is why we have this merge function
Yeah,
taking a slice instead of just a
yeah,
node.
exactly.
Because in
Yeah,
this case, we don't want to, yeah.
yeah,
So
and
here, all
that's
we do is we fix up the count of A. Index of A is already correct. We don't touch the count of B because the merge function doesn't care about that.
yeah.
And we don't fix the index of B either. We just fix the indexes after B if B is not the last node.
Okay,
Um, and we already know A is not the last node, so we're fine. And so then we just pass that to here and pass only the slice of remaining B. And so this
yeah,
avoids that copy
yeah.
of,
That's
yeah.
perfect. Like this is now like that advanced merge, and that's great.
Yep.
Here this branch. This is where if can I just check upstairs again? We've got remaining A is greater than equal to half. Otherwise, we know that A is less than a half. And here
Yep, that's why I should
yeah,
put the assert
that's
there just to like make it inflexible. If you like
awesome.
screw around these if statements, and then
No, I
you
love
can't break
it.
this.
It's great, Isaac. Yeah, so here we know B is more than a half or a half. So we set A's count to what is left in A. Then, then we go and fix up the indexes after B. And we use our merge, which, okay,
I could probably delete the second half of this comment. This is just like an old comment that we've been
yeah,
copying around a lot of places.
yeah,
Um,
cool.
we can, I don't know.
Yeah, that's fine.
I think this code, the comments don't really help very much. You kind of just have to get in the right mindset for this code and just sit with it for a while and get familiar with all the little bits.
Yeah, yeah.
Um,
We could drop that assert up top unless we want to bring it down here too. Uh,
this one,
yeah,
yeah, we can probably just get rid of it. It's already clear that B is an invalid node.
yeah,
Um, all right.
cool. Okay,
Now we're on to
and
the case where
they're both less than
both
half.
the A and B fit inside one node.
Yeah,
So they're both less than half full, in fact, as well.
yeah. Nice assert. Yeah,
Just it's the same. Well, this one's actually slightly. It's actually slightly more precise than this assert.
yeah.
I think.
We can drop
Yeah,
that one then. That
I
the
like this
first
one
one is
too because it also puts you in the right mindset for this branch.
yeah,
This is where we just say array counts is remaining A length plus remaining B length.
yeah,
So it's good to assert that that's less than their capacity.
yeah. That's good.
Um,
The first one is more specific. So it's nice
it's
because
more
the
like
first
just dealing with these two branches before us, and this kind of like tells you why we're doing what we're doing here, I guess.
yeah.
Yeah.
Okay, cool. Then we copy B into A, and then
Yep.
B is now empty, so we remove B. A's count is the two of them together. Uh,
B's
okay,
count is 0, so we can remove it. Then we do this thing where we say C equals B. And we say if we just remove the last node, there's nothing else to do. Um, I'm fine with the early return here, I guess. We could also
yeah,
get rid of it though and just, I
yeah,
don't know. That's the only one we have left right now.
yeah,
But it's hard if he wants to get rid of it, but
yeah. And
yeah.
here we do a simple merge, right? This is just what
Um,
the next node.
yeah, because we have copied, so yeah, here's another simple merge, I guess, if you want to call it like that,
Yeah,
where we copy, yeah,
yeah. Okay, cool, cool. That's a simple merge down there. And then if we go up, the middle branch has got the tricky merge, that one. And then if we go up a bit more, um, that merge is simple as well.
By simple, you mean that the next node has valid metadata and the elements are already at the start? Is that what you mean by simple?
That's it. Yeah. Yeah.
Okay. Yeah, that's true
And
for all these except for this one here.
exactly. Yeah. Yeah. Cool.
But because my feeling is that because we need this one to be correct, we might as well just use that code for all the other ones too. Then there's less code to maintain.
Yeah, but I think
Like,
what we can do is the tricky merge we can simplify because there's maybe one branch at least in there that it doesn't need because that's only for the simple case. So we can make that simpler. Just deal with the complexity it needs to deal with. And another advantage is, you see in the final else branch here where we do C equals B, we can actually, what I think we should do is the branch before this, do you see how we update indexes? We do if B is less than node count minus one. I think we should like literally copy
yep.
that there and do that. And then now we know that the indexes are correct. You see, we can copy that exact style. That still works even if B is the last node.
I guess you're saying like just
Yeah, so after we remove the empty node, we immediately update the indexes. Before we get to that last node check. So just before the
okay.
C,
So we're gonna
before
check if it's the last node first,
we don't
but
need
then
to.
instead of returning, we're gonna do the indexes.
Uh, we don't actually need
This
to.
this is this another way to check if this is just checking if it's the last node. That's what this check does too.
Yeah,
Same
but
check as here.
okay, but hear me out. So if we do what's nice, immediately after removing the empty node, we update indexes if we can. Then the rest of the function, if we have a simple merge, the rest of the function is going to be a function call, and we're simply going to pass B. No, we're going to pass A. That's it. And then we can drop the C equals B assignment and all of that. And then our simple merge is going to decide if it needs to merge or not. And it's going to have internally, are we already, is the node that we've passed, is that the last node? Okay, just return early.
So are you saying to update the indexes before we remove B?
No, so after we remove B, we just copy that. And we do.
Except it's not going to be the same though. It won't be B plus one, it'll just be B.
Okay, well then we can do it before we remove. So where we can do it straight after we update counts, like we do upstairs.
Here?
Yeah, upstairs we update counts, then we do indexes. That's fine. Then we remove the
Get rid of
node.
these indexes.
Yeah. And then literally after remove empty node, we'll have a function call. We'll say array. We just need a name for it, but like merge simple or compact. Or we can call it array merge and merge slice.
I'm still not seeing how you're getting rid of this if statement.
So that's going to happen inside the merge. So
Why?
So just let me if we try it out, let's just go for it, and then we can see afterwards. I'm totally happy if we throw it away. I just want to try it and see what you think. So do like straight after array remove empty node at, we'll have another function called array array merge node with next node. That can be the name, merge node with next node. And then all we do here is we pass in A. That's it. And internally, that's going to check, is it the last node or not? If it is the last node, it doesn't need to do anything further.
Okay. We can just implement that in terms of this function if you like.
Yeah, sure, sure.
Um,
But I also want to try and simplify the tricky merge to remove branches from there that we don't need. So we keep the two things separate. So just let's give it a shot. So we can drop the C equals
okay.
B, all of that can go.
Can I do like a quick commit first, just like to save the state of the repository before we do this stuff?
Yeah, totally. Because then we can
Um,
compare, you know.
yeah. Oh, yeah. Is this how I wanted it? I think so. I think this is how it was. Let's do a commit.
Cool.
Whoops.
You know, we almost there. Well, we are there already. We are
We
there
are
with.
there. We've been there.
Yeah, yeah, yeah. It's just basically an idea to see can we make it even easier, or um, but then we're done. You know, then we onto level zero overlapping, and that's pretty tricky, and range queries. But then we may be out of Mirkwood. Yeah.
Just failing to type my password. I'll be there in just a second. Sorry.
Cool, cool. Go for it.
There we go. Got it.
Nice.
Um,
Awesome.
now we can redo that stuff you were talking about.
Yeah.
Um, keep on going with where this branch takes us.
We can actually call it merge node with next if necessary.
That's what the current one also does, actually.
Yeah, yeah, yeah. No,
It's
I
just
know
the
that.
name is not good right now.
No, it's cool, Isaac. I mean, the next one does everything. It's like the Swiss Army knife of merge functions. Yeah, cool. Okay, so everything after that function call can go. The early return, all of that. And then we can go and use the simple merge up above in the other three places. You can copy this call up top.
And so you want to like get rid of. What does this look like then? This looks like this, I guess. And you get rid of this check, right?
Yeah,
It'll handle B being 0.
exactly. Yeah,
But you still need to update the indexes, so we do it
yeah,
like this, I
yeah.
guess.
We still need to, I think we need to remove the node if it was empty. We need to remove the empty node.
Isn't this supposed to do that? That's what we're saying it does down here.
No, no. All that function is going to do is it's going to take both the nodes in that function exist and they have elements. And the metadata is all valid.
Wait, it has to handle A being the last node though, right?
It'll handle A being the last node, but otherwise, if A is the last node, it just returns. But the nodes that are passed in there are
Okay.
always valid nodes, valid metadata, and they've got elements. So we just have to do the remove
So,
empty node at B if necessary.
so B could be empty. So what is this? Do we just take this case,
Yeah.
like stick it up here,
Yep.
and then return? What do you want to do here? Are we just using else for this?
We
Or we
don't.
still need to actually update the indexes though first.
Yeah, we want to do that. And
I'm gonna do that first then.
it's nice if we always update indexes and counts together. And then we unconditionally call that simple merge.
Is that right now? I think
Um,
you need like a return here, like an else here then.
so if B Okay, yeah. So if B is empty, we already know that A is more than half, so we don't need to call merge node. If B is not empty, then we want to call merge node with next node if needed, passing in B, not A.
Yeah,
Yeah,
good
yeah.
call.
So what we could even do, yeah, we can check if it's empty and then remove. Yeah. Or we can make that an early return. It doesn't matter. Maybe it's nicer just to make it an early return. I don't know. It doesn't matter.
I don't really care either way.
It's just a special case. And then at the end of the function, we always merge.
I kind of think this should go inside here because it would factor out some more common code. Because we're going to do the
Okay.
same thing here.
Okay, cool.
This should just go inside our merge. If you pass an empty node here, it should just delete it instead of doing any merging.
Okay.
What do you think about that?
Let's see. Maybe we can do that, and we can call it remove or merge node with next. And it can handle both. Yeah. But
Then we don't have to do the special case here.
yeah,
I think that's better.
yeah. And then that function is still simple because the metadata is all correct. The only thing is that the node we pass in may be empty. Yeah.
Yep. And here it's the same thing.
Yeah.
Just remove or merge with next.
Yeah.
Node with next, node pool, and cursor.node.
Yeah.
And here we were just doing that for that. And then if it was empty.
Yeah.
Yep.
Cool.
This assert is useless, and then we get that comments we decide to get rid of.
Yeah.
The other ones at least.
Yeah. Okay. And then
Having to write this function, I guess.
yeah.
The simplest way, let's first just do it in terms of this other function we already have. Then we can see how we can refactor that around.
Yeah.
Or merge node with next. This will take just a node or array self node pool node to void. And so currently it's just the only thing we've changed is that it handles the case where node is empty. So we just need to say if node. I just want to get the test passing again, then we can like play with it more.
Yeah. Sure. Sure.
If array.counts node equals 0, we're going to say array.remove empty node at node. Else, it's kind of just putting that if statement we had outside of this inside this function, which is already a nice little improvement, I think.
Okay.
And then we're gonna here say like const call array that merge node with next node pool node, and then array dot node. We call it counts or count? We just call it we call it nodes.
Counts.
Yeah, nodes. Node. That question mark 0 dot array dot count. This needs to be node +1. Whoops.
Nice.
Not quite. I messed up something. One more brace.
Yeah.
And an L randomly got there from whatever reason. Now I think they should test. They should pass the test now again. I think.
Yeah.
We'll see. Oh, I've
Just the naming change.
moved empty node at. Oh, this needs to take a node pool.
And
And
that
here
one
needs to be called the right thing. Remove or merge node next.
Oh, and we've got a double remove there, Isaac. In that previous branch, we can.
This one? No,
Yeah.
this is moving B. And we call this an A.
Okay. Okay, cool.
Something else didn't compile though. Or what happened here? Messed up something. Attempted to use null value. It's the last node, so there's nothing to do. Or if we just return if it's the last node too. If node is the last node.
So we do need to have the.
Just that's what that is. Node count. I think giving like 20 compilers are the same thing.
Yeah.
I need to get a different Zig version. Anyhow, this passes the tests now.
Cool.
It's a slight cleanup, I think. We got rid of some of the logic here.
Yeah.
We unified some of the logic here.
Yeah. So can we just go through these branches now? There's only one place where we've got merge node with next. So I'm thinking what we do is like merge node with next. We can call that merge node with slice, or because that's kind of what it is. We're just passing a slice that's going to go into A, right?
It's a slice from the next node though, which is kind of important.
But the next node doesn't really exist because it's not in a valid state. So I like that we just pass a slice to it.
Okay. But we have to know that the slice into the, I guess we just put the slice in the next node.
Or what we can call it is append slice, because that's really what we're doing. We're taking a slice that we add to the end of A, right? Or do we do more?
Not necessarily. We may put it into B as well. The slice could be will be either everything will go into fit into A, or the slice will partially fit into A and partially fit into B.
Okay.
It's definitely possible that some of the slice stays in B.
Okay. Okay, cool. Let's not worry about the name yet. If we go in there, are there any branches that we can now take out that are only required?
No, because we've got this implemented in terms of this. But
this one now, I don't think we hit this now. Well,
this one?
Well, so what I mean is, let's implement now our simple merge, because
this is where I think we're going to start doing the opposite of cleaning things up, and instead of making things more complicated by trying to split this function into two. So right now, I think this is nice that we've cleaned this up and kind of factored out this logic.
Yeah. The thing is
probably
that we can't assert now because we're going into a function that we're using a function that does a lot more than we need it to here. So what I want to do is now just do a simple merge inline there without any more helper code, so that you can see it straight up. And then I'm pretty sure that'll allow us to remove a branch from the more tricky one. We're basically taking the complexity and we're splitting it up into two functions, making the more complex function much simpler, because it's already like very complex. So I'm not, I mean, we just, let's try it.
It's only like 70 lines, right?
Yeah, it also, this splitting it up feels, from the beginning, it feels more intuitive. But
It's
let's
only
just,
50 lines.
yeah,
And
let's
most of
just,
it was a lot of asserts too.
yeah. So you see, in the simple merge, we can already assert that the B node has elements and that it's greater than half.
Yeah, and we can do all those asserts just by sticking them in this function.
Yeah.
And wait, the B node has elements that's greater than half. No, we can't, because the B node might be the last node in the array.
Okay, but then we can check that too. Uh, the thing is here,
Don't we have it? We have that here as well. We have well, we have B elements that length is greater than 0.
yeah,
And it's greater than half, or it's the last node in the array. We've got those asserts already here.
yeah. Okay. Let's just try it out and see. So
Yeah,
I think this first branch we're not going to need in the end, but let's just go for it.
let's think about that.
So let's first implement the simple merge without going into this one.
And see that we need that first branch for the simple merge, or what? Because this branch is for the simple merge, I believe, mostly.
Yeah, yeah.
It's just an optimization.
It's
And in
basically,
this case, we know that B length is greater than or equal to half. We're merging now. Yeah, we're merging A with B. Because A is less than half. We know
yeah.
that B is non-zero. You see, we can hit this branch still, though. Is B... Actually, no, we would hit that other branch. Never mind. We
Okay,
can't hit that branch in this case. You're right.
cool, cool.
So let's just start another function then, or I guess we can just fill out this function,
Just fill out that
or just
branch.
copy everything from this function into that function. It's probably
Yeah,
the way to
okay,
go.
okay. There will be some stuff we don't need, and then we can drop that, obviously. Uh, so I think here we should use an early return so that we don't get too nested. So we just say if the node is empty, just remove it and return. Then we've dealt with that
Sure.
case. Otherwise,
Otherwise,
if we are the
no,
last node,
if,
then we can return.
yeah,
What do you think?
sure. -1, return. Otherwise, we do this.
Yeah. And then we can do a new line before that if as well.
Sure. We div exact.
Cool.
Give them the comment to you. I think it's fine.
Yeah. There we go. We've got A and B. You know what? We can actually already call it A, right in the function signature.
I prefer not to do that, to be honest. Because this A might mean something different to what the function calling this uses A for. And so I don't want the function calling this to like
Okay.
you should pass its A to this function because it says A in the function signature.
Okay, cool. Okay.
Is that cool with you?
Yeah, sure. And then shall we say
Should be
A,
using A here though.
and instead of A pointer, we can call it A elements.
Yeah, so I changed this actually while I was while I made everything work while you were away.
Yeah.
While I was on lunch break. Because I feel like A elements should refer to the slice of A that are actually valid elements, not to the whole memory of A's node.
Okay.
That's why I changed this, and that's what I used for B here. Because here I have B pointer and B elements.
Yeah.
B elements is actually like the elements inside B that are valid, and B
Yeah.
pointer is the whole memory of these
Okay.
nodes.
Much better. Yeah. Good call. Great.
That's kind of the distinction I was making there.
Yeah.
Um,
Great. Great. B pointer and then B elements is elements.
it should be B or pointer B count. I don't even know if we need this variable now, to be honest. Could probably just get rid of it in this
Yeah.
version. Yeah, because now we have metadata.
Yeah.
Probably just get rid of that for now until we know we need it.
Yeah.
This is then B count, all these asserts.
And we already know that B can't be the last node.
I was going to get rid of this assert part of this.
No, actually B can be the
No,
last
B
node.
can be. A can't be.
A can't
Yeah,
be.
B can totally be the last node still.
Yeah. Okay, great. And then total A count plus B count. And then we say here, so A can't be empty now. So that first branch greater than 0. Cool. So we can drop that branch. Okay. So it can, yeah, we can have total greater than, in which case, well, sorry, yeah.
Do the same thing.
Yeah, now everything in B fits in A, so we copy B to A.
And just do it like that instead of having a B elements variable is fine.
Yeah, that's nice. Then it's more symmetrical with A
Cool.
pointer.
Yep. And here, B. A pointer, A count up to A half, B. This is now where having B elements would actually be kind of nice. I think this is just B pointer up to. Never mind. This is actually fine.
It's fine. It's nice because then it matches A pointer, and you see us working out the counts.
So here is where we then need to copy from. This is fine now. If B half, indexes A, counts A, B less than half. Yep. And then A is already at least half full. Do we allow it to be called in that case now? Where A is already over half full.
We can assert then that it can't be called.
Are we sure about that?
We can just check if it's.
I think we do call it here if A is over half full.
Yeah. Okay, then it's fine. Then we should allow it.
Yeah. We don't actually need to do anything in this case, I'm pretty sure. So there's no more fixing up of B's elements or metadata to do.
Yeah.
So we can just delete that part.
Yeah.
And then here we're asserting, well, we already said that A is not the last node, right?
Yeah.
Oh, wait, this is the wrong thing. Whoops. I should leave that from the wrong function. This is the function I want to delete it from. So here we assert, or we say if node equals if the last node returns, so we can't have this case.
Yeah. We could also upstairs there, Isaac. We can assert that node is then less than node count.
Where? Or like right after the return?
Sorry, just before.
Oh yeah, here.
We should probably do it right at the top of the function before we even use node into counts.
Sure.
Great.
That looks like it'll work now.
Yeah. And then if we go down here, we've got two branches. It's kind of like our old branch that we had.
This one, you mean, or what? What are you talking about?
Our
This function?
simple merge. There's those two branches, and then
Yeah.
at the end we assert that a counts is greater than or equal to half. We could also assert that a count is now equal to a count plus b count. Can we do that? Or no, we
No.
can't. We can't.
Do that inside this branch, but it wouldn't be very useful, I feel like.
No.
We just add b count to a count.
Yeah. You know what? Maybe what we must do is, you see the end of our second branch, we've got nice asserts on both counts. We can actually just hoist this assert right at the bottom, just hoist it into the first branch after remove empty node at.
Sorry, which assert do you mean?
That one.
This assert? We should
Hoist
just
it,
move to here.
yeah, into the end of the first branch. Then it's
You
symmetrical
already
with the
duplicated
second.
in the other branch, actually.
Exactly, yeah. Yeah.
I kind of want to get rid of this new line here.
Yeah.
All right, this seems like a pretty simple function now.
Yeah.
See the test still pass. Nope. Array counts a is greater than or equal to half in 454. Right here.
Yeah.
It must be the last node. Can we return in that case? I see. Yeah. The B could have been the last node.
Yeah.
We just removed B, it was the last node, but it didn't have enough elements to bring A over half. So you can't do this assert, or we have to put it back to how it was with the
Oh, okay. Or, yeah.
or there we go.
Nice. And then our, so now, of all the branches, they're all using this. Then there's a lot less power exposed to them. Now there's only that one branch that uses the merge with slice. So can we take a look at that one and see what we no longer need there?
Yeah, sure.
I think it's only maybe one branch.
It's just one branch here only.
Yeah.
And so in this case, we know that B is greater than or equal to half B length, or remaining B, the slice we pass to merge with next. And A could be empty. A could be, A must be less than half, but it could also be empty.
Yeah.
And B could be the last node. No, it can't be the last. Well, it could be the last node, but it has at least half elements.
Yeah. Yeah.
So yeah.
So we could even see if we can inline this function here.
I don't know about that.
Okay. Maybe it's going to be too long.
That's going to be too much, I think. Because we do need to, I think the only case we can really get rid of is this one.
The first one.
Can we get rid of this? I think A could be empty, so I'm not sure we can.
Okay. Oh, of course. Okay, so we need that.
Can B pointer be, no, that's the thing, because the B pointer can't actually be at the start. That's why we can get rid of it, because this condition can never be true.
Yeah.
Can assert this isn't true.
Yeah.
or is greater than.
Greater
If we do
than.
greater than with pointers, I'm not sure.
It's pretty cool, that new
We'll see.
change, hey? That you can do pointer arithmetic just without pointer to
That's
int.
actually been there for a while. You can't do it with subtraction yet. Subtraction hasn't been implemented yet, but it's accepted.
Yeah.
But addition you can do on many pointers for a while, I think.
Okay.
Addition with U sizes.
Yeah. Nice.
Let's see about tests passing. Yeah, we can't do that. We can say not equal,
Okay.
or we can use the.
Yeah, let's use pointer to int.
Yeah, that's what I was about to say. This is just a stronger check.
Yeah.
To int elements pointer is greater than to int.
Okay.
Cool, that passes.
Yeah.
So
Shall we pull
this
that?
code we just have duplicated.
Okay.
I really want to just write one of these functions in terms of the other one, though. That's what's bugging me so much about doing this. Like, I feel like we shouldn't have this code, which is also not trivial, just written twice.
Okay. Well, then let's rather do that. The more tricky merge is implemented in terms of the more simple one.
We can't do that, though, because its features are a superset of the more simple merge features.
Yeah. It's okay. Like let's just, where we do const total, let's drop that new line afterwards,
Oh,
if you
yeah.
like. If you like, up
Yeah,
top
we
there.
did it up above, too.
Yeah. Can we step through it? So the 2 can fit into 1, so we do that. Otherwise, a count is less than half. But we actually already know that. The branch that we call this function from, we already know that a count is less than half.
You sure?
Yeah, we assert it there.
Can it be equal to half, though? No, it can't be. Cool.
Yeah. So the else branch can go. And then yeah.
Nice.
So now what I
This
think
is
we
where we
should,
can move up.
yeah. Now what I
Are you
think,
seeing what we should be doing here? Um,
yeah. What are you thinking, Isaac?
I'm still thinking we should just implement, because now we've got the exact same control flow here as in the other one. And so I think I was missing like these two special cases at the start to eliminate those things. And then we can just call this function now from here to do the same stuff that this is doing.
But just check, because I can't see with the scrolling. Are they literally exactly the same, what they do?
Yeah, this, this, they're
Okay,
exactly the
cool.
same now.
Okay, great. So then
So
at this point, um, it has gotten simpler though, right?
oh, for sure, yeah, this is helping.
Mm,
I think we should
yeah,
just, I think at this point we just get rid of the rest of this function and call the other one. Are you happy to do that now? Because it's as simple as
yeah,
the other one is.
yeah.
Cool. And so here we have all these asserts here. So this is just now at this point
So
we can now call the other one with the right slice of B. So we're just going to call array that or the name still needs to be fixed. Yeah, the name is still bad.
yeah,
Node, and then we need to pass in the slice of the next node elements. So we need to do next elements equals array that nodes node plus 1 dot then we pass in next elements here.
Yeah.
And then we're done. We can just delete all this stuff. And then if the test passes, we've actually made things much better, I think.
Yeah.
Yeah, that would be
It's
the wrong thing to use there. It should be counts.
Counts, yeah.
Oh.
So
yeah.
what we want to do there is maybe bring that into the call site, that special call site where we actually jump straight into a merge. But we don't have to. We can drop it out also.
This is the assertion, though. We can also just drop the assertion, I think, and then we're fine.
Yeah.
Yeah.
Yay, awesome.
And at the call site, I think it's obvious that. Well, we might as well just bring it to the call site. Yeah, well, let's look at what the call site looks like, I guess.
Yeah.
This here. And so what we would be asserting is that remaining b dot pointer is greater than here we're here. Because just kind of assert that this is not equal to 0, maybe that.
Yeah.
It's greater than pointer b, I guess, is what it is. We actually assert that up top, though. I think we don't have to do it down here. We can just do it right here.
Okay.
I think that's my intuition.
Yeah.
It's probably nice to have. Yeah. Cool.
I'm glad I'm helping because you asked me to, like, you got the whole thing working and then you said, let's check it, see if we can simplify it still. So I'm glad I'm able to contribute just a little bit, you know.
You're definitely helping out here. I feel like I really just need to just stop talking and just get my brain totally focused to just get the code cranked out and make it work.
Yeah.
And now I'm happy to discuss style and making it better and whatnot, because you're definitely helping making it better. It's definitely better than it was when we started talking about this.
Yeah,
so I'm happy with that now.
Cool. I think this morning also we spent too much time wondering if it would be better or not instead of just writing both versions and seeing. Because
we really should have just. I should have just but I don't know. I feel like sometimes I can work better if I'm just not discussing anything and just keeping everything just in my head and not really having good ways to explain it, but just doing things and then seeing how it works out.
Yeah. Yeah. So I think I like now it's gone well. We just at lunch you just tried it, just did it, see how it works out. And now also we just tried this other approach and just see if it leads somewhere. And then once you actually do it, it becomes evident quickly, whether.
Because then you can do these. What we're doing basically now, code transformations, stuff we see though it doesn't change the behavior of the code, but it makes the code simpler.
Yeah.
And that's so much easier to do than to write code from scratch with the perfect structure, because then you're not sure if the code's right or not yet.
Yeah.
So I feel like we should have actually. I don't know. I feel like next time when we hit some problem like this where we're just not making progress for a whole day, then I feel like we should just maybe stop pair programming and just try and just write it out, or just stop trying to make it perfect, but then just really get the code working first. Just pass the tests and then make it pretty and maintainable.
So I was just thinking if we do it like this, where we take the two cases. The simple case, we deal with it separately. The complex case, we deal with it on its own without trying to do the two together. I thought that's just going to be easier. And actually now we kind of realized we arrive in a happy medium, where I think the thing is
we should have better abstraction.
We should just both, because we're both working on it, if we've both got ideas, we try them both out and just do it and see what
I
like
feel
we've
like it's
done.
most important to just get the test passing first.
Yeah,
And I saw a clear path to that point by just making my one big weird function,
yeah.
and then
It's
that made
just
the control flow here simple enough I could reason about it, and then it worked.
yeah,
Um, so
for
the problem before was that we had our control flow here was just too complex to reason about, and
yeah,
so it was not clear what order we wanted these branches in and whatnot, and so I abstracted away enough into my big function that I could then reason about this control flow and work out this part.
yeah.
Now we've like
So
come back, and now
yesterday
we also don't have any
morning,
code duplication either,
no,
and so it's
exactly.
really
But
clean now.
yesterday morning, I was kind of already thinking of this that we can do it like this and it'll be easy. So I was kind of then we going along and trying out the branches, and that's why I thought, no, we've got to go back. But yeah, I'm glad. I mean, it doesn't matter. Hey, Isaac, this has been super tough. So, and we've only done two
Yeah,
days on it, and we've got it working, and we've got a nice. I mean, this is better than I thought. Like I didn't realize that we could collapse it in the end, like this.
yeah.
Yeah,
I also didn't realize that. This because those two special cases I had here, actually are covered by these two things here.
yeah,
These are the same checks, but they're so much simpler to do ahead of time.
yeah,
Um,
yeah,
and that also makes the call site simpler somehow too, which is just sweet.
yeah.
No, like call
But
sites are always just, yeah, you do update the metadata, um, update the indexes, call your function.
yeah,
Here too, it's just like do this and call your function.
it's
You can
very
skip updating B stuff.
it's very simple.
So,
Yeah. And
and
you
we
know
don't need to
what
comment anymore.
what you were saying also, like just get it working, not worry about if it's pretty. I was also feeling the same. I just thought let's just get it working with the two. Do the
Yeah,
simple cases,
I
do the
feel like
complex
our
case,
ideas of
and
how to get it
then
working were different though.
yeah, yeah.
Um,
Well,
and that's also totally okay because like what works for my brain doesn't have to work for your brain too.
no,
Um,
no, but it leads to a better result than what I could have done or what you could have done. It's
exactly, yeah.
yeah,
I mean,
that's what it's
after
about.
I just finished it over the break, I was ready to just like, okay, the tests are passing. I don't want to touch this anymore. I'm done.
Yeah,
But now we've made it better, so that's
cool.
good.
No, also like you, I mean, well done. Like you're like Frodo, right? Carrying the ring.
I don't know. I mean,
And
Samwise like Curious Roto up Mount Doom. So
yeah, 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 yeah. Sometimes I feel like Frodo too, with the deadline and things. So it helps that you can be, um, yeah, that we pair programming this. Yeah,
cool. All right, so we had some ideas to make sure like we hit all the branches here. Just like what would be
yeah,
really nice is if we had a code coverage tool for Zig or one that worked with a Zig. I think there are some that can just use dwarf debug info. We should
yeah,
try and set that up sometime. It'd be really nice for our VR fuzz testing too, just to
yeah,
see if we're hitting all the branches we hope we are.
yeah.
Um,
And a simple way that we can just hook it into our unit tests and everything.
yeah, that'd be cool. That'd be worth spending some time to develop.
Yeah,
Maybe not before our deadline here, but it'd be worth just investing time into the Ziggy ecosystem to develop that for our use cases here, because
yeah,
that could give us a lot more confidence about our tests.
yeah. Could we do it that
Um,
we basically have some helper function and you give it a pointer to the struct you're testing or to the code you're testing, and then you sort of hook it in your unit test, you run your test, and it's going to check that all the branches in that code were covered. Or
um,
is that am I talking
I think
magic?
you're viewing it too related to the source code. How code coverage is usually implemented, kind of, it's runtime instrumentation, right?
Yeah,
And so it sees what branches the CPU takes at runtime based on the
yeah,
generated code. And then based on the dwarf debug info in the generated code, it can then refer that back to, or like link that back to the source code.
yeah,
Um, I don't know all the details yet. I haven't done that much looking into this, but
yeah,
I think we'll see that it actually happens a little bit differently than that. It'll
yeah,
more like be or like what percentage of branches in our resulting binary get hit by the tests.
yeah,
And so that would be, and then we can also see like then what branches specifically got missed, hopefully. And
Yeah.
so then it can give us like a list of branches in the replicate code that we're missing. And we can then filter it by like branches in the replicate code or whatnot, hopefully.
Yeah.
That's kind of what I'm picturing
Cool.
as the interface to that. And
Awesome.
so we could have like, it would say like, we run the tests and then the tooling that runs the test, it'd be like running, you'd have the same test binary from Zig, but you then run this under some like code coverage tooling that then puts into instrumentation calls or whatnot. I'm not sure exactly how it works. Then it would like spit out a report that says, okay, you hit 90% of the branches in your replica code. And then we have
Okay.
to like, and then list the branches we missed, and then we have to go figure out how to fix those.
Awesome. Yeah, that'll be so cool to do, you know. Yeah.
For sure.
Um,
And I think that's definitely, yeah, something the Zig compiler wants to support for sure, but
yeah.
it's not there yet because there's other focuses
Yeah.
so far.
When I was chatting to Will Wilson from Foundation DB last night with the testing work that they're doing with antithesis, like the deterministic hypervisor running, Linux containers and fuzzing them and all deterministically. So he was basically saying that they can already hook into LLVM stuff to get the code coverage.
Cool.
Yeah, but it would
Their
be
LLVM has
nice.
got some level of code coverage implementation stuff
Yeah,
then. So I
yeah,
should look into that then.
yeah.
Neat.
Shall we take a 5 minute break?
Sure. Yeah, and then come back and I guess work on testing, or
Yeah,
I guess we want to insert these asserts we were talking about, or the panics in the branches to make sure we hit every branch.
yeah. I thought we could
Um,
also do some stuff like here, just this array index is one. We can move that one line down and group it with the next line, um, so that we keep all our index update logic
oh
together.
yeah, yeah,
And
just
then,
like cosmetic code cleanup. Maybe add some comments that aren't crap.
yeah,
Because we deleted a lot of comments that didn't make sense. Now we've got no comments left.
yeah,
Or
yeah,
almost no comments left.
yeah. We could do. I thought we can just polish the code, just check it out, and test it.
Sounds good to
Do
me.
yeah.
All right.
Okay.
See you in
Nice,
5 minutes or so.
nice work. Great.
Thank you.
Testing, testing, testing. Hey, Isaac, can you hear me? We back on?
Hey,
Okay, cool. Great.
we're good to go. Can you hear
Yeah,
me all right?
yeah, I can hear you. Good. I just switched off my headphones by accident, so then I had to get those
Uh,
inputs, outputs hooked up again.
cool. So yeah, I guess we should just start from the top here and work on
Yeah,
through.
yeah.
This here is still fine, I think. I've changed the assert, I think. I changed the assert here to say half instead of allocate count or count less than equal to half. This is what I changed. It used to say
Okay.
no capacity there.
Oh, great. Good catch.
Um, yeah, let's just keep on going down from the top, I guess.
Yeah,
Data is removed from only one node. That's a useful comment.
yeah. Maybe we can say if elements are removed from only one node.
One node.
Yeah,
And then here it's like elements are being or
removed.
remove elements from
That's good. Elements are being removed from only two nodes.
exactly two nodes.
Okay, yeah, exactly two nodes. Maybe that first comment we can bring down also to be at the top of its branch.
Sure, yeah.
And we can say
I like that
there,
style better.
yeah,
And
also,
then or we can say remove elements from exactly one node.
yeah,
Then it's not like passive.
yeah, that's much nicer.
And remove elements from exactly two nodes.
Yeah,
I kind of like a new line there. It's about the whole branch.
okay,
What is this? This is now. So you see, we've got like a naming issue here where we call this element instead of pointer, where we
yeah,
call it pointer down here.
yeah,
I think we should just call it pointer.
yeah. And I think what we should even do is introduce A here. A equals cursor
And
node.
just call it A.
Yeah, and
Yeah,
do,
let's make it more should we use A like way up top here then? I think we should. We use it the same in every branch then.
yeah, yeah, that's great.
Yeah. I'll delete some of that code in just a second, but here we can do A, pointer A.
And let's actually call it A pointer, if that's okay. Because then we can have A pointer,
Oh,
A
that'll change
remaining.
our style from everywhere else in it. Like we do pointer A everywhere
Yeah,
else here.
yeah,
Oh, we call it B pointer here. Oh,
exactly. Yeah,
okay.
because all the others are qualifiers. So we should switch it around to do,
Interesting.
yeah,
I think it reads kind of funny there because it's like a pointer, that's the sentence, right? Like a
yeah,
pointer is this, a pointer is red, a pointer is blue.
okay, yeah. We've also got like A half, A head. Uh,
This seems also inconsistent there because we say elements A, elements B, but A pointer, B
yeah,
pointer.
I think those other ones, elements A, we should flip around and make it A elements, B elements. It's just that
A elements reads even weirder. I guess we
it's
have A half, B half though.
it's fine
Okay.
because it's our style where we always put the qualifier after.
Yeah, and if you say, oh, should this be A existing tail then instead of existing the A tail?
So there we made it that the biggest thing is existing versus elements, and then
Yeah,
existing A
so
tail, existing
then
B
A
head.
should be after elements, right?
Yeah, yeah. Okay, so that's fine. I think this function we shouldn't worry about. We
Okay, so just like use B pointer here.
yeah,
We can delete the old code now too.
yeah.
Um,
Maybe we want to actually. I think we should leave it, Isaac. Keep that there because it would be pretty nice to run our test before and after check. And what I was thinking we should run our test with the old single insert or single remove, and we use time to time how long the test takes, and then run it again with our new batch stuff. So we've got a nice number tomorrow we can share with everybody.
I think
Like,
I think we already deleted the old single insert and remove, but we can bring it back for that purpose.
okay.
I am curious though. Yeah.
Yeah.
Good point.
Okay.
Just make sure we haven't wasted our time the past week.
Yeah. We would have learned something anyway, so.
For sure.
Yeah.
I'm pretty sure we haven't though. It definitely felt faster.
Yeah.
And theoretically it must be faster.
Yeah.
Unless LLVM is really crazy.
It's got to be crazy to be a optimizer, to be a compiler. Like there's some stuff that it does. It's good.
Yeah.
Yeah.
So where are we at now? We're renaming this to be B pointer and A pointer
Yeah.
inside this function only.
Yeah.
Probably inside our helpers too then, right?
Yeah.
Use the same names inside here, I think.
Yeah.
Also too long, I should wrap this. Oh, look, we use B pointer here already.
Yeah. And you know what I was wondering? Should we have an else branch in here with an assert? Actually,
What do we assert on?
okay. What I'm wondering is, do we sometimes, because we're passing a slice in here, sometimes we do nothing with that slice. So that's okay.
Yeah.
But that's fine.
Well, no, because we actually, in the times we pass just a slice in, it's always like true that the A is less than half. Where the slice is not at the start of the array already.
Yeah.
So we should so we can do this actually. We can assert that the slice pointer is equal to the B pointer if this is not true.
Okay.
Assert. Thank you for this. This is a really important assert actually.
Yeah.
We can assert that B pointer equals what's it called? It's B elements dot pointer.
Yeah.
That's a really important assert to have, and it will fail if we then mess up and pass in a slice that doesn't start at the beginning in a different branch then, because we have to allow it for these two branches, because these can be hit from this one branch where we do pass in the slice.
Yeah.
These can be hit from this branch.
Yeah.
But this branch guarantees that A is less than half, and so we can put the assert here.
Yeah. Cool. And I like actually our naming. We've got remove or merge node with next, and then we've also got merge node with next.
This should be I think this should be like merge node with next slice though or something. But I guess that the argument has made that clear.
Yeah.
In the comments.
Yeah. What we could do in this
And so,
function, what we could do there is we don't have to, but merge node with next, we could have, instead of taking in node, we could call it A, and then we could call it B elements.
I don't like that because at the call site we might not use the same terminology for A and B. We already have it here where our A here is the B at the call site in many places.
Yeah.
Okay.
No,
for example, here or not there, but like somewhere else, I'm sure here.
Yeah.
Yeah. So I don't like to put the A and B stuff in the function signature. They should always be like local to these one-letter variable names should just be local to your function, I feel like, and not be exposed in the public API or whatnot.
But it's kind of like a sort comparator function also. We'll take A and B as the arguments.
Okay.
That's kind of what I was thinking. But I'm happy we can leave it like this.
I really do prefer it like this, and then
Okay.
just assigning A and B locally.
Yeah.
And then I think it's also slightly easier to or slightly harder to pass the wrong things here. Because it just feels weird to see your function takes, I'm mostly, because also when you do sorts, you usually don't have an A and B in the scope calling this sort is the thing. The issue is more that we have A's and B's in the scope calling this function,
Exactly.
and then
Yeah.
we would have to pass them in with different mismatching names here then. You have to pass B to A and then C to B or something like that. And that seems bug prone or just confusing.
Yeah.
Um,
Good. I'm with you. That's good.
well,
So, okay. So we were busy hoisting A and A pointer outside the scope entirely. Like I think even further up, right?
oh
Uh,
yeah, we have them here now.
yeah.
A pointer. So we can get rid of those here. There are we can compile it if we don't do that because it's
Yeah.
shadows. Um, remaining A also we can host up there, can't we?
Hoist. Yeah, because we
It's
used
just
to use it in the first branch.
we don't actually use it there, I don't think, because we don't care about it. We don't use it there, so I'm just gonna leave it here, I think. Um, we even use it down here, or if we just use remaining A dot length, I think we don't never actually use the slice itself. Um, yeah, we're never gonna use the slice itself. We're just gonna use the length. Um,
Okay.
funny.
Then it's actually good if
Remaining,
we change the type into just a count.
probably, yeah. Here we do copy B though.
Hmm.
I think it's also nice though because it's symmetrical with the remaining B. And the compiler will just optimize that away. It's not really a big deal. Um,
I was thinking more that if we make the types not symmetrical, then it's impossible to misuse them. So where we're thinking to
oh, that's a
pass a
good point too.
slice,
'Cause then
we
you
can
can't mess them up.
exactly, yeah,
Um, we just make this one a count then. It can just give me
yeah,
it's just cursor relative index. That's all it is.
yeah,
Um, we also just stop using remaining A and just use relative index everywhere. But I think that'd also be confusing.
no,
I
yeah,
think
no,
remaining A is a better name.
yeah, a
Um,
remaining.
oh,
We'll,
good point.
we'll have A remaining, B remaining, but B remaining will be a
Yeah,
slice. Yeah,
let's do it like this actually. We first just fix this one, A remaining, and then these ones, oh, we fixed it once. Just A remaining, and then B remaining will be a slice. Remaining B, B. Did I spell those correctly? I think I did.
yeah,
Nice.
yeah. And
Cool.
we should
A
check out
remaining.
our first branch as well. We can still plug in
Yes.
a pointer even above this. Yeah,
Oh,
up top.
here, yes.
Yeah,
We need to get rid of this, yeah.
yeah.
We also need to, so we have now a pointer, cursor.relative index. I
So
think,
there we
oh,
could be using
we
a
could use a
remaining.
remaining there, to be
Yeah,
honest.
yeah,
Why not? Uh,
yeah.
um,
And then it's going to look similar to our mem copy in the third branch, I think.
plus count. Rate at counts, cursor.node, it's now A. Yeah, I like this. It just gets cleaner and cleaner the more we work on it.
Yeah,
It's
yeah,
very satisfying.
yeah.
Um, yeah, node count. In cursor, we only actually use these two, for these two items, node
Yeah,
and relative index here, is all we use cursor for.
yeah,
We shouldn't use cursor again anywhere.
yeah. It's
Use it
actually,
here and here. These can be
uh,
fixed though.
and then that's
Um,
also nice because we know that we then don't have to worry about invalidating the cursor. We're, if,
indeed, yes.
yeah,
Um, so, I mean, it wouldn't actually, it invalidate our A and B's too,
mhm,
Um,
yeah,
anyhow, so cursor is now used for it's only used these four places in this function.
yeah. It would be cool if there was, I don't know if it's possible, but you could have a keyword that can erase something from the scope after a certain point.
Yeah, it would be handy for stuff like this. It's possible, I'm pretty sure.
Yeah.
I feel like it might be a rejected proposal though. I think someone's already discussed that, and there were some issues with it.
Okay.
Um,
Yeah.
I'm not sure. But I guess the issue with it then, well, how I would do it is I would make it still a compile error to use it to then shadow it. Because the first issue I would see is if you erase it and then make a new one with the same name, that
Yeah.
would be bug prone.
Yeah.
But if you actually forbid it to making a new one in the same scope, so you keep the shadowing of it, but you
Yeah.
forbid using it again, that'd be useful, I think.
Yeah.
And so one argument against that is like we already have the feature like just block. So you make a block and then
Yeah.
have it like go out of scope with a block. But because we don't have tuples yet, maybe once we have tuples it'll be okay. But right now it's awkward to just like return these two things at once from the block.
Yeah.
While keeping them constant, because you have to like make a struct then, and then you have another thing in your scope. And so it doesn't solve the problem at all.
It's also like a rare enough tool, and you'll hardly reach for it. And probably a lot of the time, one could also argue that, well, maybe you should just change the code flow so that you avoid that in the first place.
Yeah, I think it's probably not worth it. I think this also came up in the context of like people complaining about the while loops not having a precondition, like to declare your variables or whatnot. And so someone's proposed like having this built in, you can then use after your while loop's over to delete your loop variable, like here. So I is not in the same scope as the while loop, and so you could then here do like something like delete or I or something like that after the loop. But in that case, it's very clear that this is simpler because it's already required in the language.
Yeah.
No,
that's fine. Yeah.
Yeah.
It's not.
And it's not like cursor would be invalidated, actually, because like the indexes stays the same. It's not like a pointer that gets. The indexes stay the same actually.
Yeah.
So this would be just as valid to use throughout the whole function as A would be.
Yeah. It's just that it would be more likely that we will see if we're getting something wrong if we use A. Whereas if we forget that cursor can be invalidated and stuff, then A is more likely to be. But I mean, anyway.
Perhaps.
I also think we shouldn't. It's not.
And so, but you see, the actual solution to this really is that Zig will eventually be able to return tuples from functions. So we can just make cursor a tuple.
Yeah.
I think we're also going to have destructuring for assignment of tuples. And so then we could get rid of this cursor variable entirely and just have like A, comma, E remaining equals this function or whatever syntax we land on.
Yeah.
I'm pretty sure that's accepted and also planned to be implemented eventually. But that's more of just like a quality of life thing that will be much longer term.
Yeah.
And one of the main reasons for that is for like you like add with overflow like math functions, and so you want to return two things from that function, like one if overflow occurred, and then also the result, but with the overflow taken into account. And so there are use cases for that that'd be made a lot cleaner by tuples. So I'm pretty sure that's accepted and planned right now.
And why not just return a struct?
Good question. I'm forgetting the answer to that. I think it just makes the code ugly. I think that's more what it was.
Okay.
It didn't feel clean or whatever.
Okay. Yeah.
We already have like tuples in the language. They're just like not very easy to, they're kind of impossible to use cleanly.
Yeah.
Like there's no syntax around them, but they're in the type system.
Yeah. Yeah. Like for printf, right?
Yeah. So for the format specifiers, those are pretty much tuples in the type system. But there's also you can create tuple types like structs without field names, and then just create them using those tuple literals.
Yeah.
But there's no real syntax around them. You can just like make them using the @type built in, like this one. You can make them using this if you don't like give your structs field names or whatever. But yeah, we'll see where that goes long term. Anyhow, back to this. Do we have any more missing A's? And we just got rid of all the cursor nodes, so we think we should be good now here.
Yeah.
The tests still pass?
Great.
Oh yes, they do.
Yep. So we do the indexes there. Wait, okay. Do we have a B count anywhere? No. Okay, but we don't want to use it. I think we don't want to introduce. It gets too confusing.
No, I don't think we want. We don't want
B-array.
any. I think we just use array that counts A and B because these are pretty short.
Yeah.
I'm not sure why we didn't do that in this function, to be honest. Maybe we should refactor that away when we get down here. Here we use A count and B count for some reason.
Yeah.
This could also be just A instead of just nodes
Yeah.
A.
That was just the
Because
result
B
of the.
count here is not nodes B. That's why we do this, I think.
Yeah. Yeah. And
We could
because
also
we've
use
got a.
B elements of length everywhere, though.
Yeah.
I'm not sure about this.
We probably should.
But
Because then
then,
it's more clear. Because count is actually like A count is the full count in A. But anyway, we can come to it now.
yeah, I think we should get rid of these variables. Let's do this now because we're thinking about it now. Because here, it's possible to screw up. If you use A underscore count here, it's wrong in this
Yeah.
assert because we've now modified A count and we want to use the new version.
Yeah.
And so, I think this is just a footgun waiting to happen here.
We can keep. Yeah. Good. I'm with you. Yeah.
And B count, let's just get rid of that too. And we were already using B elements at length here.
Yeah.
So it's just like not consistent. It's not good.
It's pretty good for a lunchtime sprint. But, oh, by the way, Isaac, do you need to have lunch?
I've had some snacks. I like kind of ate a bunch of dates and almonds while I was programming, so I'm not that hungry.
Okay, good, good. So you had like a
Energy.
good combo, energy and protein. Yeah,
Yeah.
nice.
Did you already for lunch? I assume you did.
I had, yeah, I'm good, thanks. But just let me know
Cool.
if you need to stop
So,
again.
yeah. I've got to get off in like half an hour for Korean anyways, so I think we could just go until then,
Okay.
till the hour. Just spend another half hour cleaning up the code and doing tests and whatnot.
Yeah. A count up there, we
Um,
just need to do also, yeah, B count there and A count.
the elements. Yep. The elements down. So here's where A count is going to get a little bit more verbose. And oh, yeah, this is so I think we should have this is correct. I think that could be like a temporary variable though, to be honest, like A half minus A count.
We can also
That
just
could be like
wrap,
V2A.
yeah, maybe let's see before that, yeah, if we wrap it,
Yeah, just
because
wrap
there's
it.
quite a lot going on.
So, I guess this is fine.
Yeah.
I don't know why I just typed that 3 times instead of just using my fancy cocoon skills. Um, it wasn't very slow though.
No.
It's like the trade-off is always like between how much brain power the special combos require versus how long it takes you to just type it manually.
Yeah.
Count minus 1. Here's another A count.
Yeah. And the reason why we can use floor division there is because we know that A already has an element. So even if we get off by 1 in the division, we'll still be greater than or equal to a half. Otherwise, we would have to use ceiling division there when we calculate A half.
Sorry, oh, are you saying that if we can't use ceiling division? If we...
Oh, yeah, well, so I was just thinking if we need a comment there to say why it's okay to use flooring division here. And I think it's okay, it's at least okay because A already has elements. So even if the floor division is off by 1 from half, it's going to be okay. But furthermore, it might actually be that we have to use flooring division here because A already has elements. Can that be true or not?
I think it doesn't matter which one we use. Do you want to try it the other way and see if we still pass the tests?
Yeah.
Um,
Yeah.
Just as a data point before we think about this much further.
Yeah.
I love just like making the computer do work for me, so I don't have to think as much.
Yeah.
What have I done this up? Oh, B elements at length. Yeah, that's one reason to make a P count, because then you have to do the int cast like 10 times instead.
Yeah.
There's gonna be another one of those. It's A half as well. Okay, that's kind of annoying. Or total is now total. See, that does it. There we go.
Cool.
Passes. Yep. So it works both ways.
Maybe it's nice just to keep it as a div seal because then it's consistent with what we do elsewhere in our
For
bulk
the
insert.
yeah, I think it could also be somewhat beneficial, because then you have a very slight tendency to push stuff towards the front of the array.
Yeah.
It won't make a big difference, I don't think. I
Yeah.
don't think it would even show up on benchmarks.
Mm.
It's probably not worth thinking about. But yeah, you're right. We do div seal here, so we might as well do the same thing down below.
Yeah. We could also add those asserts afterwards that we had
Oh,
up,
do we have
up
asserts
top.
up there?
Yeah.
Div seal this one. Yeah, sure. I think it's a little bit cramped here. I might just like put a new line there.
Yeah, that's
But
nice.
Dig the format doesn't want me to.
Oh man.
Yeah, so it doesn't actually let you do that unless you have a comment. I guess it's fine.
Yeah.
I know the code that does it. I wrote the code, or I've touched the code that does this part.
Nice.
A counts A half, B elements, A half minus rate counts A, that's all right. B pointer, area half, yep. All just assignments here. So here, we need to update the comments for this function perhaps a bit.
Yeah.
Well, it's kind of tricky to know what to say with the comment. And we assert that, do we allow node to be empty still? Should we assert that array, I think A's got to be greater than 0 now. Or no, do we still have that one case, A can still be empty, I think.
I think it can't. Yeah. Because it can actually, if it depends on how we're getting in here. If we get here direct, or go through our simple merge.
Yeah, can be empty, and so, but that's fine there because we'll just hit this case because then total is guaranteed to be less than or equal to node capacity.
Yeah.
And we've now, we've seen that we don't have a pessimization here either. It's not like kind of encoded. It's not really encoded well in the code, but we know that B pointer won't be this won't be true if we're coming from the past where A can be empty. So we can do an assert on that though, actually.
Okay.
So this is a kind of tricky assert. We need a comment here. So if this assert fails, then we are doing an unnecessary copy of all the elements of B in the first branch below. That's what this assert means. And then the assert is assert, it's kind of what our if statement here used to be.
Yeah.
If it's kind of like if array
Counts A
counts
0.
A. Yeah. So this is really good. Then we can assert that this thing is not true.
Okay.
Then wrap this line somewhere.
Yeah. And there where we say unnecessary, the unnecessary just needs another N after the U.
Oh yeah. I think I messed something up. N-E-C-E-S-S-A-R-Y. There we go. Gotta double check that spelling.
Yeah.
All right. So we can also express this assert as assert without the if statement and just do like that counts equals 0 or this. That would also be fine. Maybe it's better like this though.
We could say array counts is non-empty, or b pointer is not equal to b elements pointer.
Is that actually correct though? I think it is. That's also slightly stronger than what we have here.
It'll actually be array counts is greater, yeah. So the first one is saying either we're doing a simple merge or we're doing a slice merge.
I kind of want to express this. I actually want to express this differently. I'm gonna do it. I think I want to do it like this. I want to say not. It's not the case where we would do this unnecessary copy. I think this is more readable with this comment in mind because it then shows exactly the conditions where you would do the unnecessary copy, where the array counts A as 0,
Yeah.
and b pointer is equal to elements pointer. So now I think it's a little bit more clear why this would be an unnecessary copy.
Is that as strong as what we had before, though?
That's logically equivalent. That's yeah. That's like if you negate. So that's just a basic logical transformation you can do. You can negate both statements and put an or instead of an and.
Okay.
It's exactly the same logically. De Morgan's law. Thank you, crypto code.
Okay, awesome. Great. I've learned something. So here we're saying that, okay, I find the first one easier because what it's saying is that we expect both nodes to not be empty at this point because we've already gone through our simple merge, which has dealt with that case of the node being empty. Or if A is empty, then we know we haven't gone through our simple merge and we're now using it in that extra case where we passed in a slice, which is not at the beginning.
I like this one because it shows you the exact conditions where there would be an unnecessary copy. It just asserts that they don't happen. It may be a little bit harder to see why we can assert this.
Yeah.
But I think it's more useful for explaining why this assert is here and why we want to assert this.
Yeah.
If we do it this way.
Yeah. So it's cool.
I think it's actually just better for like maintenance. Like someone's going to come back and look at this assert and be like, why are they asserting this? But now it makes a little bit more sense because it's just like an optimization. We could explain then a bit about why we can assert this.
I wasn't thinking of it in terms of the copy, but just in terms of how the function can be called.
Well, the whole if we weren't trying to the thing is that this case wouldn't be incorrect. Our function would do the right thing here.
Yeah.
If this assert failed, our function would still do the right thing.
Yeah.
But it would unnecessarily copy all of B into A and then delete B instead of just deleting A.
Yeah.
That's what we're trying to avoid. And so that's why I think expressing it like this is more easier to understand.
Okay.
At least for me.
Yeah.
What
we can do
our
is
function.
make
So
the
let's just state
comment.
that. Just say our function would still be correct because assert fails, but we would serially copy all elements of B to node A.
Yeah.
And then delete B instead of simply. I just want to write down what I just said, explain to you. Ding A.
Yeah.
I think that's a better comment than this.
Yeah, that's great. And then the simplify there, we must just change to simply instead of simply deleting A.
Oh, yeah.
Yeah. What this assert is also doing is that it's checking that we called this function correctly, like whether we went through remove node. Because remember, most of the time we always call remove or merge, which will then come through to here. So it's also checking that, but both
Yeah.
are true, and it avoids the copy if it's called correctly.
Yeah. I just want to make it clear that we don't do this assert for correctness, but rather to
Yeah,
as an optimization, or to ensure that we make this optimization.
yeah, cool. Perfect, Isaac. De Morgan's law.
De Morgan's law. Yep. Cool. Do we do everything we want to do here? We kind of got distracted from doing something up top, I think.
Yeah,
Um,
we were still hoisting a pointer and all of that.
You're right,
Yeah,
because we just hoisted this stuff and we just kind of finished with this branch, I think. And now we're
yeah,
gonna start here.
yeah,
Shift remaining elements in B to the start of the node. That's a nice clean copy. Somehow like managed to make like really concise copies
yeah,
for these ones.
yeah,
Because just having the slices already made, like we already have B remaining being the slice we want to copy, and so
yeah.
it's pretty easy to copy that to the
I
right
like
place. And this
I,
copy,
li I like
yeah,
the control flow we have here, like the A remaining greater than half, B remaining greater than half.
yeah,
That's very
I'm
nice.
I'm really happy with how that worked out
Yeah,
because, and also that's kind of like the stuff that I was just struggling to figure out yesterday. And then all the merge stuff in one function really helped me reason about this stuff because then I could like kind of see how it needs to be used.
yeah,
Um,
that's great. Yeah. It's also nice because these are simple conditions. They're not compound. So it's
exactly, yeah.
just checking one
And
thing,
so
checking another
it's
thing.
much easier. And then you
Yeah,
handle all the other cases at the end with some asserts.
yeah,
Um,
yeah,
cool. Elements. And this is pretty straightforward too. Just oh, we don't even need this anymore, do we?
yeah. We don't need that.
Something here.
I think what we should do is have a helper to do all our index updates. Um,
Oh, okay. Um, like just decrement following indexes by,
yeah,
and an
yeah,
increment following indexes by. I
yeah,
feel like the helper would only save us like, or would it also check for this for the node being in range?
yeah.
Like we
It
would
could.
just call the helper unconditionally, and the helper would check if the node's
Yeah,
less than the last node.
yeah,
Okay, I buy that, I guess. So we do this how many places? I guess we do it 1, 2. Yeah, this definitely could use a helper. 3,
yeah,
4 times. Yeah,
yeah. And
I'm
we
sold.
we also do it. We do it when we increment as well. So we could add a direction as an argument.
I
So we
think we
get.
should keep it specialized to decrements. I think we only do it like twice in the increment, or even once. We do it once here,
Okay.
and we only do it twice here.
Yeah.
Then it's also going the other direction.
Okay. Oh, here it's still going forward, right?
Oh, so actually, we don't need a direction though. We can just like put a minus sign in what we call it with. Just
Yeah.
pass a delta.
That's
Um,
what I thought. Yeah. Well, okay, yeah, I didn't. Yeah, I was actually thinking of it. Just yeah, a delta's better.
Okay, so I think we just call it like modify following indexes,
Yeah,
and it doesn't touch the node you pass, but touches all nodes after the node you pass.
yeah. We
Cool.
can say
So maybe I should put this like down further. I don't know. Where's this go? And after all the remove
yeah,
node helpers.
yeah. It's common to insert
Actually,
and remove. So
yeah. Whoops. There's no next. I guess we still have. Yeah, that's still a thing. Then we have the old remove element. Then we got remove empty node app. We still need this one.
yeah.
Okay, so I guess I can put it down here. So fn modify
Oh, we can call it
follow.
adjust. Adjust indexes after node. What do you think
I
of
think it's
that?
just after, and then you pass in node.
Okay.
So it'll read like adjust indexes after a, and then
Okay.
I
Cool.
think that'll be nice.
Cool.
Node u32
And delta,
and oh yeah, delta,
which will be
which
signed.
now needs to be what do you want to make this? It'll be signed. It'll be
Just I32.
and the indexes are, however, an
U32.
u32. I guess that's what we have to do because we underflow will be
Hmm.
yeah. I'm fine with safety checks just panicking if the math goes wrong. That's what we
Yeah.
want it to do.
Yeah.
So we're gonna say if node is less than array dot nodes or node count -1, then we're gonna say for node dot indexes or node +1 to array dot node count. Star index. I'm gonna call it star index here. I think it's a little bit nicer than I. I'll do index dot star plus equals delta. So probably need to be like incast. I think actually we need to do it like this. Index dot star equals incast I32 index dot star plus delta. That's what we need to do, I think.
And then we need to put it back into a U32.
Oh yeah. Annoying. Oh. That's fine though.
Hmm.
It'll make our call sets definitely easier or
Yeah.
better. So let's test it out. Remove indexes after, or adjust indexes after. Man,
Yeah.
got a lot of code in this file.
Yeah.
Adjust indexes after b, and then minus count.
Yeah.
And so the problem here is that count is a U32. Minus. This gets kind of ugly, doesn't it?
Yeah.
Um,
Maybe what we should do then is just pass in a U32 and pass in a sign separately. So
or I kind of think, yeah,
so
that's
we
definitely make this variable conversions a bit cleaner.
yeah. So you just
You can
pass
also just
B
have two functions that says
decrement indexes after B, increment indexes after B.
exactly.
Yeah, that's better.
Oh, I don't have a function yet. Adjust.
It reads nicer as well. And then delta can
It
be,
does, yeah.
delta can just be count then.
Yeah, or just amount, or I think delta is still good actually, I
Delta
think.
is good. Okay.
Still a delta.
Yeah.
And then we have increment as well, just because. And the increment we can actually put up with the other helpers then for insertion.
Maybe we should put the two together though, so that we can compare them.
Okay, fine.
Yeah.
That's fine with me actually.
Yeah.
And I don't mind this code duplication at all.
No.
I'm not bothered by it.
Yeah.
Um,
We could even use I and make it a one-liner if you like. The loop. Now that we've simplified how we use
sure.
delta.
Because now there's no casting weirdness going on.
Exactly, yeah.
Still good, yeah, cool. And then goes delta. Whoops. There we go. And now this one we've already used once, I think. Document
Yeah.
index after B. I guess I can group that with the counts, so it's all metadata stuff. Then remove empty node add, and then
B.
it's like a slightly weird. I think this copy should go in its own line. Then we got metadata. We got remove empty node, and then remove. I think these two could almost be together.
I was going to say that too. Yeah.
Cool. I'm glad we're agreeing on this stuff.
Each time you suggest
must
it,
be right.
I'm about to suggest it as well, you know. Yeah. Yeah.
That's right. Yep. Man, look how much cleaner this is getting. Awesome.
Cool.
Now we need to go up with that.
Yeah.
And this. Last one. Whoops. I want decrement. Oh, hold up. If I messed up the variable here, I didn't really check. Yeah, that was a B. That was also a B. Yeah, the other one was a B too, so we're good.
Okay.
I'm going the wrong way. Hold up.
I think we just went too far back.
Here we are. We're good now.
Okay.
And this was a B that I just deleted. No, this is an A. See, this is why I wanted to make sure I was messing up.
Great. Good catch.
There we go. Now it's correct.
Okay. We can move those away from the mem copy as well, if you like.
Oh yeah.
Okay.
And you know, we were always like talking about getting rid of the counts metadata and just having indexes. Still haven't done that, but
yeah. Maybe we should see. Maybe we kind of use counts a lot, you know.
we do. But what we would do is we would replace it with a function that gives you the count.
Yeah.
It would just be like array.counts instead of it being an array index. It would be a function call.
Yeah.
It's just like a little inline function that does a tiny bit of math on indexes.
Okay.
Then you can't use counts if you made indexes out of whack. So I'm not sure if that's a good idea or not. It may not be that bad. I think it would actually be pretty easy to replace.
Yeah, I think we should try and see if we can do it because it'll save a lot of static allocation or a fair amount.
Yeah, I think it is a pretty good chunk. Yeah, it's cutting our metadata by a good amount. And it's also done like less state to keep it in sync. 'Cause then the only metadata is now the indexes then.
Yeah.
And so. Okay. Now we gotta fix those increment indexes calls too, or just like make them better.
Yeah.
Just right here, isn't it? Yeah. commit index after B. Yep.
Yeah.
And by
Elements length.
elements.length. Whoops. There we go.
Nice. And then we can move all that up next to the counts as well. Or do we want to keep it separate there?
Sure. I like it like that.
Yeah.
That's just gotten more concise.
Yeah.
Okay, and then the same thing here. And this is now cursor.node.
Yeah.
What if we should hoist up A here as well? Like we did down below.
Yeah, I think so.
Maybe we should like not do that on the same commit though. That could be like a different refactor.
Okay.
Otherwise, this commit's already gotten pretty big and messy.
Yeah. But you know, if we are already touching the insert path here, so hoisting it at the same time is not a problem.
Okay, so we just hoist up. So we use relative index down here.
Okay.
Like a fair amount.
Okay, maybe then
Not
yeah,
too
make
much.
if we should then.
I think we should just refactor this. I think if we want to do this, we should just do it in a separate commit.
Yeah.
And this should just be just adding this one function. I guess we can also get rid of that, but then also put the copies in their own space like this.
So when we do that, what our goal will be to kind of do what we did for the first branch on our remove path, where we use
we'll move a pointer up above here.
Yeah.
And then get rid of this. Yeah.
Yeah.
We can do that. So I can add a to do here, if you like, so we don't forget it. To do. Have any other to dos in this file? Release fast, standard library, import this type from LSM Oh, look at that. We've already done these things.
Yeah.
Well, some of them at least.
Yeah, we've done 3. Now next up is level 0.
Yeah, so I guess our next task is to just come through and get rid of these to dos or resolve them.
Yeah.
If we can. The to do move the A through def or
Yakuba's gone live as well on Twitch.
Cool.
I just got a ping.
And then he was like working on elf stuff recently.
Okay.
And he goes incremental linking for Linux going, or self-posted linking for Linux.
Yeah.
Which is pretty sweet.
That's awesome.
All right.
I love it that Zig has got its own linking stuff going.
Yeah. It's also like just required to do the kind of incremental compilation we want to do. Like there's no way to do that without implementing your own linker.
Yeah.
And so yeah.
Yeah, it's worth it, you know, like vertical integration, owning the stack.
Oh yeah. Taking total control of your whole stack is very empowering.
Yeah.
Let's see if this thing still compile and work. Yeah, that's what I thought. Yeah, I've used the wrong variable name. Right here, array.indexes.
Yeah.
Yeah, it works. Cool.
Yeah.
Anything else we need to do? Or are we like kind of done now?
We can maybe remove elements batch. Just start at the top and go down, step through the branches. We've got that comment, remove elements from exactly 1 node, from exactly 2 nodes. We've now introduced B pointer, B remaining. Then we assert with A remaining, shift remaining elements in B to the start of the node. We could keep our comment style the same here, add a new line.
It's talking about literally this line though. It's not talking about the whole branch.
Okay, of course. Okay.
we could
Maybe
say,
these branches don't need too much actually.
just drop this comment then? I mean, it is kind of obvious what this name copy is
Yeah,
doing.
yeah,
Yeah. That's telling a what, not a why, so it's probably not,
exactly.
it's not high level enough to really be useful. So I'm
Yeah,
happy with that. Man, these branches really got a lot smaller.
yeah,
That's cool. They all fit on the screen now.
yeah. Nice.
Sweet. I'm happy with this.
Yeah, very, very nice. Oh, Isaac, if we go up a bit,
Yes.
um, this is all in the else branch. And if we go up,
Yes.
uh, up top is just a single branch. So what we could do is make that an early return, and then everything
You
else
could, yeah.
can have less indentation.
That's fine with me, yep.
I think we do that also on the insert path as well.
Yeah, we do. We handle the one node case first
Yeah,
and do an early return.
yeah.
It's a fine way to do things, I think.
Yeah, I mean, it's up to
Can I
you.
help
If
with
you
something like line length?
maybe,
I'm
I don't,
I'm happy to have less indentation. I think it's good.
okay,
I'm happy we don't have like like many early returns. We just have one. It's
yeah,
like I think keeping that sane definitely helped me reason about this stuff earlier, but now we've kind of gotten rid of all of them anyways without
yeah,
any more branching control flow.
yeah,
I'm quite happy with how this has worked out.
yeah,
I don't want to make, we can make, I mean, the other thing we can do is make these ones also early returns, but I think these ones are kind of nicer, like all like this.
yeah,
Um,
yeah. That's
Now
fine.
I feel like this comment should come outside the F then.
Yeah,
Um, Now the comments are on the same level again.
yeah.
Cool.
We should also add a comment why we restrict the batch size to half so that we can only affect at
Yes.
most two nodes. Just up there,
That's
yeah.
this right here.
Hmm.
So I like pull this one, so I just comment in the middle of the assert block.
Yeah,
Uh, the, the batch, the removed, the elements are removed from at most two nodes. That
yeah. That elements are removed
most
from at most two nodes. And then the ensures, we just have to put the S at the end of the word. That's it. Maybe we can also lower the half there to be just before where we use it. Where we
right here.
define half.
Yeah,
Yeah,
sure.
what do you think? Okay,
Fine with me.
yeah. And what we could, okay, we need count to verify absolute index. Okay, cool. Do you want to, maybe we can add a new line after count greater than 0, and then a new line after count less than equal to half. Yeah,
I'm happy with that. Yeah.
yeah, okay. If you want to hoist
So
half right
we
to the
could
top,
also
it's also good.
bring this one like down here, or
Yeah,
okay, we could do it like that too. Okay. Yeah. And then
yeah,
something like
that's cool.
that.
That's nice, yeah.
All right.
I think the node count greater than 0, that could be right at the top. because that doesn't even relate to the arguments, but to the state of the array itself.
Sure. We're just like reordering this and reordering this.
Yeah, that's cool.
Seems good to me now.
Yeah. Shall we just do a quick once over? Have you got like 10 or 30 seconds left still? Or do you need to run?
Sure. I think we've done one once over already, though.
Yeah. Yeah.
I'd be happy to just commit this and then come back and play around more with the tests and get resolve the reviews next time and do the once over with fresh eyes.
Fresh eyes, yeah, perfect. Let's do that.
Cool.
Shall we just check the tests that they pass?
Oh, sure.
Okay.
They pass.
Awesome. You know, it took us 2 days to get inserts working in bulk, and we've done the same for removes, and it was much harder.
It was much harder.
Yeah, nice work. Yeah, really nice.
Thank you.
Yeah, awesome lunchtime sprint.
Yeah, it was definitely a very productive lunch.
Yeah.
Like when you logged up, I just kind of like didn't stop. I just went through.
Yeah, cool.
Did all my branches and made my code messy, and it worked. And then we made it really nice and beautiful.
Yeah. I didn't want it beautiful. I just wanted to do the too simple, just split them and just to do it.
Yeah. I wasn't able to. That wasn't working for me somehow. I needed it to all be at once, so I could like do the high level control flow first.
Yeah.
But yeah, how's the forest coming along? Very nice, Christoph. We've now optimized the remove path as well for our segmented array, and so we can now delete nodes in batches or delete elements in batches.
Yeah.
But we're just about to sign off for the day. Just writing up a commit.
Yeah.
Well, let's just WFP first.
Yeah, so also now we've basically done one of the toughest structures. We've got everything we need for our in-memory manifest, and we've just got 1 or 2 tough sections, we think, to go, and then we're going downhill again, and we're kind of getting out of the forest now, out of Mirkwood. We're getting towards the end. Yeah.
And just squash these things together and make a nice commit message.
Yep.
These are all remove commits that have just been WIP'd. So here we're going to say lsm. Well, what do we call the other one commit?
Optimize segmented array batch removes.
Yeah. Moves. And do we want any comments to add there? Are we good?
Just in the comment, just put a well done exclamation mark.
All right. There we go. Yeah.
Hey, awesome work, Isaac. It's been tough, but we've made it.
We pushed through. I did not know that segmented arrays would be so hard to implement, or to make performant. It's really the batches that get you. The batch inserts and removes are tricky.
Yeah, me too. I didn't think so, but I'm so glad we've got it. It's very nice.
Oh yeah.
Yeah, thanks everybody for dropping by. Great to see you all. And we'll catch you tomorrow for the Tiger Beetle sessions. Thursday, 3rd of February 2022, session 17, signing off.